So the guy that figured it out is, of course, Isaac Newton, right? So Galileo described how motion works mathematically. Acceleration down, position goes as t squared. Descartes, I don't know, he put some math on it. But then Newton is really the big one that figured it out. And I want you to know Newton was a little bit, the nice word is eccentric, okay? Newton wasn't much of a people person. So he discovered the laws of motion we're going to talk about. He invented calculus, and he invented most of optics. He figured out most of optics. Yet on his deathbed, he told the doctor, "My greatest accomplishment is that I will die a virgin." That's what he said. That's actually kind of the opposite of an accomplishment technically, but I'm not going to nitpick Newton, okay? So I'm doing a really horrible job of selling the physics major, I know, right? No beer, no sex. Come on, who's on, right? Let's go. It's the greatest major. So Newton said, he looked at all this and he started to figure it out. He said, okay, let's just jump in with Newton's first law, okay? And this is something that you can probably, it's almost sing-song-like. You can probably recite it. Oh, I went into Old English for a second there, sorry. So, and let's all say it together. Maybe we'll say it together. 1, 2, 3. An object in motion remains in motion. I can't write and say, and an object at rest remains at rest unless acted on by a net force. An object, okay, that didn't work. An object in motion remains in motion, and an object at rest, I really should use PowerPoint, remains at rest, right, unless acted on by a net force. So if you want to be a famous physicist, no drinking, no sex, but if you make up a law that you want to be famous, make it kind of sing-songy. Make it fun to say. An object in motion remains in motion. An object at rest remains at rest unless acted on, and this is kind of the coda that kind of sucks, unless acted on by a net force. I don't know what a coda is. Fear you won't call me on that. Okay. So let's look at this and see, there's a few little parts of the sing-songy version, though, that you got to get a little more specific. So he wasn't super specific the way he worded it, because it was more about the style, you know, the music part. So an object in motion, what does this mean? Remains in motion. What does that mean? So he's just saying constant velocity. Unfortunately, I broke it at the end there. But that's what this means. It remains in motion. If you read the original, if you get out your Principias and read the original Latin, it's not, he didn't exactly say velocity. He said there's a state of motion, and he basically meant velocity. Right? And then this is an important part. It's not unless it's acted on by a force. It's unless it's acted on by a net force. Right? We know that force, so I'm going to tell you that force is a vector, and you can add up a bunch of vectors to get the total vector. And it's the total force that matters. What's a force? Let's define a force. A mathematical push or pull. In the unit is newtons, which is abbreviated N. Okay? So all your forces will be in newtons or maybe millinewtons or micronewtons. And 1 newton equals 1 kilogram per meter per second squared. 1 newton equals 1. We'll see the formulas later. Kilogram meters per second squared. And we tend to think it's always been that way. Probably Newton named the unit after himself, right? No. So the unit of the Newton was invented and it was declared in 1946. Relatively new name of a unit. If you could have Einstein try to do your homework, you're like, I don't know what the hell this is. I mean, what's a Newton? Yeah. Where's the dynes? But remember, though, force is that it's in newtons. Objects can experience multiple forces. Can experience multiple forces that sum like vectors, that add as vectors. Add. We are going to do some math today, I promise. These are just the basic facts that we have to write down. Okay? Newton's first law and forces. That's all you need to know.